Okay, so we've made great progress so far this semester in terms of where we're at in Unit 1. I think we're in the tail end of Unit 1, and after today's lecture, we might be able to start discussing the first test. We won't do the test until after the first homework's due. I'm going to push the homework back. I think I haven't done that yet. I'm going to push it back to next Thursday. So we pretty much, though, we've already talked about data modeling. We've talked about what an algorithm is, and then we talked about the 5 fundamental building blocks that are required to build out our algorithms, to implement our algorithms inside of Java, right? So we looked at output operations, we looked at storage operations, we looked at input operations, we looked at the processing operations, and then finally, we looked at the control operations. And in the control operations in particular, we looked at selection statements and we looked at repetition statements where we can repeat a block of code or we could select a block of code from multiple blocks. So with that said, what I kind of want to piece all of this together with is go over a lecture that goes over a algorithm design strategy. So we're going to talk about the top-down stepwise refinement process, and we're going to keep coming back to this process throughout the semester to utilize a methodology by which we can start with a concept. We could start with what we'll call a top statement, which is like a single sentence explanation of what our application is intended to do. And then from there, it'll provide us a tactic, right? A plan on how we can expand that so that it's a fully defined algorithm that's effectively in pseudocode, so that it's a fully defined algorithm that maps one-to-one from our English explanation into our Java implementation. So again, one of the most challenging concepts for junior level developers, for people just learning how to develop code, is to figure out how to grow out, how to plan out, how to define a complex algorithm. Like how do you take what you want to create, whether it's a video game, whether it's an application that allows you to go ahead and process your taxes, whatever the objective of the code is. One of the most challenging things is figuring out how to get from an initial idea to a fully implemented deployable project. And so I'm going to show you a strategy that's commonly referred to engineers all over. And let's go here, and we'll actually take a couple look at examples too as we progress in our capabilities throughout the semester. Okay, so the tactic is one of two things: either functional decomposition, and the reason why it's going to be called functional decomposition is because we're going to learn how to identify what methods we're going to have in our code base. So that part we're going to come back to later on, because we haven't really learned how to define our own methods yet. We're only using one method, the main method. But understand that functional decomposition and top-down stepwise refinement refer to the same thing. So right now, we're going to take a deep look into the top-down stepwise refinement portion of this strategy. And later on, once we introduce the concept of methods, we're going to revisit this and see how we not only can evolve a thought into a complete algorithm, a complete pseudocoded explanation of our algorithm, but we'll also see how it can help us identify how to break our code base into different functions and classes. Okay, so we don't have to review any of the repetition statement. We're going to jump right into this. So let's talk about and here, let me put this in the title. Oh, no. Let's do paste without formatting. Perfect. Okay, so let's talk about the top-down stepwise refinement process. So there we go. So top-down is an approach by which we start with something very abstract and we incrementally add details until it becomes more complex. So it's a strategy that allows us to design complex algorithms in a very straightforward way. So again, what I want you to visualize when I say top-down is think about having something at the very top. You have just a little bit of information. When you start with your applications, usually that's what you're going to initially start with, some idea. And so the idea is, how do you iterate across that idea, that concept, that thing you want to do until it's complete enough so that you can start implementing in Java? So the big takeaway here is that you should always pre-plan what you're going to code before you ever touch your keyboard, before you ever start putting anything into a code editor. You should understand what your algorithm is that you're going to encode first and foremost, right? You shouldn't just be spitballing what you want to develop without considering how it's going to operate, what the data model is, how you're going to follow the step-by-step directions. You should always pen and paper that first. Okay, so let's take a look. So we typically break down the top-down stepwise refinement, where the top statement is where you start. You traverse down with each additional refinement. So that's what refinement means. We take what we initially started with, and we start with the top statement, and we keep adding details. We look at the latest refinement that we do, and we ask ourselves, is this so well defined? Is this effectively pseudocode? Pseudocode is like Java code or Python code or any other code, except that it doesn't compile. It's a human, readable, interpretable set of statements that define your recipe, but it's designed for you to plan out in your head what your algorithm is. And once you have suitably well-defined pseudocode, the idea is that you can then translate it into any actual programming language, whether it's Java or Python or C++ or what have you. Because all of those programming languages make use of the same building blocks that we've spent the last 3 weeks or so covering. So our top statement, we start by defining a statement which serves as a one-line summary for the application. That allows us to define the specifications of the software and know what our goal is. So then after we've defined our top statement, which is effectively the elevator pitch of our software, we move into the first refinement. So this is an iterative approach. That means that we start and then we iterate. We look at what we previously made and said, what is abstract? What is not so well defined that I can't directly translate it into a Java statement? And if you look and see, oh, this statement says a lot, I can't just translate that into a line of Java code, then you have to do another refinement. So the first refinement, the next step, is to add more detail to the statement, which better defines how those tasks are accomplished. So effectively, you never change what's happening from the top statement for every refinement. It's always defining the entirety of the application, but what you're doing across each refinement is explaining how you're implementing it a little piece at a time. So effectively, it's a strategy like divide and conquer, where you define a little bit, and then you examine it, and then you identify a new part that's not so well defined, and then you define that. So it allows you to start taking this really abstract thing and defining it in a more concrete until it has a one-to-one mapping to Java. So for instance, in refinement 2, we would add even more detail to the set of statements from refinement 1. And we continue to do so until the set of statements is well defined enough to serve as our pseudocode. So finally, at our refinement end stage, that represents the last refinement step before no more details can be added. Each line of our pseudocoded algorithm should now map to a Java statement. And once you get to this level, you should be able to paste the refinement into a source code document and use it as a guide to implement your application. So again, pictorially, and here, let me give this a, so pictorially, one way you might want to visualize what this process looks like is almost like a pyramid, right? We represent the evolution of our algorithm where we start with the top, and the top is the peak where we have very little information. It's very abstract. And then after the first refinement, we've expanded it out more. And then after the second refinement, we've expanded it out even more. And then after the third refinement, we've expanded it out even more. Until finally, at the very base of the process, we have the most expanded, the most defined, the most like elaborate of algorithms, but that's going to help us because then we could take that pseudocode and then directly implement it into Java. Is there any questions about this? Does this kind of motivation, does this idea, does this design pattern make sense, at least conceptually? Perfect. So it's one thing to kind of talk about it. It's another thing to actually see and be challenged to do this in practice. And of course, when you go to design your own software, I would encourage you to practice at this because you only get good at these endeavors the more you challenge yourself to try it. So you shouldn't just be doing Java code, but start thinking about how you can start planning to design code and not just implement code. So in this lecture, we're going to use that top-down stepwise refinement approach to design. Actually, we're going to do 3 applications. We're going to start with a grade averaging application that uses a counter-controlled loop that averages 10 grades. And then we start by walking through the top-down stepwise refinement process. We're going to create a like counter-averager.txt file where we would step through and build out our algorithm. I'm going to do that on our PowerPoint slides instead of actually a TXT document. But if you were to do this yourself, you'd open up a TXT document and just start writing out your pseudocode. You start with the top statement, then you do refinement 1, refinement 2, all the way until you felt good enough about what your pseudocode represents to be able to then convert it to Java. The next application we're going to build in this lecture is going to be a grade averager that uses the sentinel controlled loop. So recall last lecture, we really stressed the difference between counter controlled loops and sentinel controlled loops. Does anyone remember what the distinction between that is? When do we use a counter control versus a sentinel control?
Counter control is when you don't know how many numbers there will be, while sentinel control you can input the exact amount of numbers.
It's actually the flip on that, right? So the counter, but yeah, that's the distinction. So a counter control loop, we know ahead of time how many iterations we have to do. So we count down or up to that point. With a sentinel control, sentinel means that there's a special value that our loop is looking for to stop processing. So sentinel control, we use a sentinel value because we don't know ahead of time how many times we have to repeat that block of code. So when that sentinel value occurs, then that alerts the loop that it should stop. Yeah, that's exactly the distinction though. So I want to really impress upon that. We saw that once before, but let's actually design an application that feels more real, something that actually performs a task. I think the application we did last time was just like printing out numbers, right? So let's build something that averages grades because that feels more real. And we could step through that process to see how we would design that. And then finally, we're going to build a calculator. And we'll use, that'll make use of the switch statement that we talked about as well last time. So we'll build 3 applications, and all of these applications, we're going to design first using this process that we kind of just detailed. So let's step through. Let's kind of do this interactively. If I was to do this counter averager, suppose I made a counter averager.txt file. And in fact, let me see something here actually. Okay, perfect. So Okay, so the first thing we start with, whenever we start planning to do any kind of implementation, is we have to think of what our top statement will be. Our top statement, again, is effectively a summary of what our application intends to do. So for our counter averager, my top statement here will be determine a student's average for 10 quizzes. It's quick, concise, one sentence, but it conveys to me and everyone else exactly what this does, right? So does this much make sense to everyone so far? Okay, so what's the next thing? So notice a couple of things that are important to indicate even at this stage is that we specified a concrete number of quizzes that we're going to average. That lets me know before I do anything else that this is an optimal target for a counter-controlled loop as opposed to a sentinel-controlled loop. Because I know there's going to be 10 grades that I need to average across. Hence why this is called counter-averager, because we know ahead of time how many grades we have to process. Okay, so now the next thing we would do if we were doing this in real time, right, is after I define my top statement, I do my first refinement. So I'm going to put that top statement off to the side and I'm going to think about it. I'm like, okay, what are, at least abstractly, I'm not going to hang myself up on the details. I want to just think, what is the next set of sequences that even allows me to start tackling this problem of determining a student's average across 10 quizzes. And so my refinement, and again, this isn't a hard science, like there's a little bit of creative decomposition that happens here. So your refinement and my refinement steps can be different, and that's okay, right? But it doesn't matter what happens in the in-between refinement steps. What should always happen is that the end result is what's similar with everyone's process. So in my first refinement, and I'm open to questions about this, would be the first thing I would want to do to determine a student's average for 10 quizzes is, well, initialize the data that I'm going to need, right? So clearly, if I'm going to take an average of some quizzes, there's going to be data that needs to be set up to be able to produce that, right? So I'm going to kick the can of what that data is, but I'm going to say, well, this problem requires data. So I'm going to put that as the first step so I can think more deeply about that in a future refinement, right? So the second thing I'm going to do after I set up my data, after I initialize my data, is I'm going to say, well, I'm going to get those 10 grades from the user and I'm going to sum them together. And then the last thing I'm going to do is once I have the sum, does everyone know what how to average? Like an average is defined by the sum divided by, right? So once I have the sum, then I can compute the average and I can print it. So so notice my refinement one, so what's now on the left-hand side is exactly, I've lost no content on what's on the right-hand side. So this, if I read these three instructions together, it still produces the same explanation as what this top statement is, right? But it's more detailed. It's giving me a little bit more insight of how I accomplished that. Now, the question I'm going to challenge you is, do I have enough information after just refinement one to directly implement this into Java?
You probably do, but maybe not every.
No, I don't, right? I mean, I'd have to make it up. Like, I would have instructions in my mind that's not on the page, and that's not the goal of this process. So the goal of this process is to explicitly convert into pseudocode every line that I want to be in Java. And so here, line one is clearly not a Java statement. It's too abstract, right? Line two is clearly not one singular Java statement. It's too abstract. And line three is as well. So what that indicates to me is I need to do another refinement. I need to do another iteration because I'm not at my pseudocode goal yet. But I've started to isolate and define things that have to happen for me to build out this application. So I move on to a refinement step two. So what I do in refinement step two is I would number each of my lines So here I had 3 statements: initialize data, get 10 grades from the user and sum them, calculate the average and print it. So in the second refinement, I'm going to focus on just the first statement in refinement 1 and say, okay, what does it really mean to initialize data for this application? And so, well, I have to think, what is an average? Well, I need to initialize, I need to declare a sum. And so at this stage, I can start asking myself, am I going to declare a variable or am I going to initialize a variable? Do I know ahead of time what the value is, or do I have to wait to do some processing across my application? So for the sum here, notice I put initialize because we know ahead of time before we start counting that a sum should start at 0. Would everyone agree with that? Yeah, before we start counting, before we do the first grade, we start at 0, and then we'll add to that whatever the first grade is. And then we'll add to that whatever the second grade is. And then we'll add to that whatever the third grade is. So by definition, the starting value before we start doing addition is 0. Okay, before we start counting the number of grades, what is our count? Do we know what that is at a time? We do. Before we start counting, it's 0. So we'll also initialize the count variable. So we've identified in order to produce an average, we need to have a sum, we need to have a count. So what we're doing is we're defining what are the independent variables. What are our decision variables that we need to have in order to process a solution? And since an average is based off of the concept of a sum and count, then I can declare an average. Now, why am I not initializing an average? Why am I declaring an average but initializing the sum and the count? Because the average is the thing I'm trying to compute. We start our sum, implicitly. We start our sum implicitly at 0. Even when we're doing that with mental math, right? Like you're not counting at -1 or +1 or 10. When you look at the first number, you're like, okay, I'm going to take that as my number 1, 70. Then I'm going to add to that a 68. Then I'm going to add to that 100. I'm going to add to that an 82. But you started at 0, whether you recognize it or not. So we want to be very explicit at what our starting point is. So we know that we're going to use sum and count, and that's what we're going to get from the user. So we have to give it a starting position so that when we start adding to it, it has a value. Now, since average is the thing we're trying to get, we don't get that until after we've gotten the user's input. So there, we're going to declare it with the understanding that we're going to need it later, but we don't know anything about it now. Like an average, we have to wait until we actually have real values for sum and count. So we'll simply just declare that. And then finally, we're going to initialize a scanner object that we'll have to use for input. So the real big takeaway here is I want you to see that these 4 lines of statements here are all based off of my interpretation, my analysis of this single statement from refinement 1. So what I've done was I took that one statement that I made earlier and I've expanded it to 4. And now it still says the same thing, right? Initializing the sum to 0, initializing the count to 0, declaring an average, and initializing the scanner object is still the same as initialized data, but it's better defined. It's less abstract. It's more concrete. It gets me closer to being able to mapping this directly into a Java implementation, right? So once I've walked through this, I look and I'm like, okay, I think that's enough. I can't think of anything else I would need to be able to compute an average for a set of 10 grades. So I'm like, I'm done with that. Let's move on to the second statement from refinement 1. And so for the second statement in refinement 1, it says, get 10 grades from the user and sum them. So, okay, if I'm going to get 10 grades from the user and sum them, what that tells me is I have to repeat a process 10 times, right? So I'm going to do that. I'm going to first put repeat 10 times. Now, what I'm repeating 10 times is going to be a block of instructions. So notice how I'm going to indent that in so that I can clearly visibly see what I'm going to repeat 10 times. So if I'm going to get 10 grades from the user, the first thing I should always do is prompt the user to alert them that my application, that this application needs something from them. The type of data, what is the value it's. We're going to prompt the user for a grade, right? So when I say get 10 grades from the user, the first thing I need to do is prompt them. Once I've prompted them, I can expect they're going to give me something on the keyboard. So then I got to use the scanner object to get that grade. But in the same line, when I get it, I need to store it into a variable, right? So I can use it later on in my application. Once I get that grade from the user, I can then add that grade to my sum. So my sum started at 0. So I would add to sum, whatever that new grade is. And then I would also add 1, I would increment the count. And I would do that 10 times. Does that make sense? And does everyone see how, well, let me go. And then once I've done that, I feel like I've done enough for this step. I can't really think of anything other way I can articulate that. So I'll move on to this third statement, calculate the average and print it. Well, I'm going to define my instruction. I'm going to expand that into this box here, labeled 3, to show you the connection between these. To calculate the average and print it, well, I'm going to set my average finally to be whatever the sum divided by the count is. And then I'm going to print that average. I'm going to print the value of that average so the user can see it. And I think that's it. That's all I need to do there. So does everyone see the connection between each of these tables here, table 1, table 2, and table 3, based off of the pre-existing refinement that I did just a stage before? Does anyone have any questions? Does everyone see how, do you feel that you could do something similar to what I just walked through? Yes. We'll look at it again with the Sentinel. But okay, so now what we want to do is we want to try to go ahead and implement this. So let's go here. Oh, no, not quite. Let's go here. Perfect. Okay, so let's make a Java file. Counter averager is what we'll call it. So let me go down to counter averager here and get it into. Okay, so if I did my due diligence and I actually created a TXT file where I started with the top statement and evolved it. So I did 2 refinement steps. And let me ask you this. Is refinement 2 well defined enough? Is it concrete enough? Is it in a format that represents pseudocode that allows me to do a one-to-one mapping to Java? Let's do a quick analysis. Or do we have to do a third refinement? So let's see. Can I initialize sum to 0? Does that translate nicely into a Java statement? What about initialize count to 0? Does that translate to a Java statement? What about initializing a scanner object for input? Does that translate to a Java statement? What about declaring an average to be able to store for later? Does that translate? Okay, so I'm done with part 1. Let's look at part 2. Repeat until count is 10. That's a looping structure, right? That has a Boolean expression. So that is, we have a count, it starts at 0, until count reaches 10, we repeat. That translates. What about prompt the user for a grade? Can we convert that into a Java statement? What about get and store a grade from the user? What about add a grade to the sum? What about add 1 to the count? Yeah, we're done with that. Finally, set the average to the sum divided by the count. Yeah, I can do that directly in Java and print the average. Yep. I feel like I now have complete pseudocode for the application I want to run. So once I have that, I might have a text document that looks like this. here's my top statement, and here's my first refinement and my final refinement. And look, last time I did this, I actually had 3 refinements. In my second refinement, I decided to ignore having to do the repeat logic and just focusing on what the code block has done. And then in the final step, I inserted the repeat logic, so it actually happened more than one time. Again, this is an illustration that I can have everyone here who engages in this can have different number of refinements. You can have different things that you identify at any given time, but the goal is to have complete pseudocode by the end of it. So the way I approach this isn't like 100% a hard science that you will always do it the same way I do it, right? This is a strategy. So it gives you a starting place, and it tells you how to take the next step and the next step and the next step, hence the term stepwise refinement, until you get to having complete pseudocode. And then once you have pseudocode, it gives you something to start building and executing and debugging if it doesn't work the way you expect it to. So what I do with my pseudocode is I make use of it. So I'm going to copy my top statement when I go into my implementation. Nope. And I'm actually going to use that as my header statement for my application. So I'm going to use a multi-line comment, and I'm going to remove top on there, but I'm going to put what the statement was. So now that anyone who comes and looks at my source code file knows what this application does. It's super important that you have a heading description in every class file that explains what this class is responsible for. And so instead of having to do that while we're writing the class, we should define that before we ever start doing any Java code. What we should also do is provide authorship, because it asserts who owns this code, who is responsible for this code, who to go to if you have questions about this code. So always give yourself credit for the code you author. Just like you always put your name on any piece of text that you write, whether it's a research paper, whether it is a novel, whether it is a short story. Same way you would give yourself credit for a piece of art by adding your signature to it, the same way you give yourself credit for producing a musical composition, you want to do the same thing for your source code. And this isn't just for vanity. This is even bigger than that. This is for responsibility, so that other developers know who to seek out if they have a question about the logic that happens in the code base. It provides you as the authority figure on this class file. So here I will put author Ted Holmberg. So moving forward, everyone, when you create your source code, should have that heading, and you can just grab it right from the top statement. Excellent. Is there any questions from this so far? Okay, so the next thing I'm going to do then is I'm going to take my refinement, my final refinement, and I'm going to paste that into, and in fact, let me do this. Let me scaffold out, before I do that, let me scaffold out my code. So public class counter averager. Okay. And then public static void main. Okay. So I have an empty class and an empty method. The first thing I'm going to do is I'm going to copy my pseudocode text, and I'm going to paste that into my class file. And since right now we're not doing since we're not using more than one method, I'm actually just going to put it all in the main method. But this is kind of premature. Moving forward, we wouldn't just put this all in one main method. We'd put it in the class definition, but we'll talk about that later when we use this for functional decomposition and not just the top-down stepwise refinement process. So here, let me comment this out. So I'm going to go here I should be able to toggle these into line comments. And so now what I have is I not only have a summary statement at the very top, but I can also use my pseudocode to guide my implementation of my Java file. And it'll give me very descriptive comments inside my code base. Now, one thing we strive to do, and I've mentioned this already, when we start developing our software, we strive for self-documenting code. That means we give good names to our classes, we give good names to our methods, and we give good names to our variables, so that as you read just the identifiers and labels, you get a sense of what I, as the developer, the architect, the author of this code, intends to express in terms of my source code, in terms of my Java expressions. Now, the pseudocode can aid in that. It shows you what the basis of my algorithm, my Java algorithm is. Okay. So let's now slowly convert this line by line. Initialize sum to a double. So, initialize sum to 0. So what does that let me know? That's numerical data, right? What are my options for numerical data? I can either do integers or doubles. I'm going to do doubles because it's possible maybe you can get a maybe you can get a fractional number for a grade. Maybe you get a 95.5, for instance. Maybe you have a half point off. So I'm going to do a double because I got to select a data type. And if I do doubles now, it's going to let me have an average that is also supports a fractional number, right? So does everyone see why I selected to do doubles? Because averages, potentially, you want to have a fractional value. You could potentially have like a 89.9, and you probably don't want me to drop that 0.9 and just make it an 89, because I might round up to a 90. So double sum, and this is initialized. So I'll go ahead and make that 0. And then here, this is going to be initialized count to 0. So here, this is something discrete. I can't have half of a quiz. So I'm going to make that an integer. Sure. These? These? Those are no longer comments. So that's a great question. So one thing is there's two different types of comments. They have what's called the block comments, which is what is on lines 1 through 4. I open a block comment using a slash and an asterisk, and then I have to close it with an asterisk and a slash. And any text that appears in between this opening and closing symbols is ignored by the JVM. It's ignored. It's treated as text comments for human consumption and not part of the source code at all. Now, line comments are an alternate way I can do comments. It's // And what that does is anything to the right of those two slashes is ignored, but anything before those two slashes is still valid code. So that's a great way for me to insert a comment after a statement where the statement will get executed, but then I can put a piece of text that doesn't get executed, that's not read. It's a great question. So here, so notice I'm going to push that comment off to the side as I implement it. And so now I can clearly see what I have done, what I have implemented, what I haven't implemented. The next thing I'm going to do is I'm going to create that scanner. Now, in order to make a scanner object, I actually have to import it, right? So let me do that. Let me import from java.util the scanner class. So now that I have the scanner class, I can go on to line 11 here, and I can declare the data type scanner. I can give it a name. Here, I'll call it keyboard. And then I will initialize it which means I'll give it a value at the same time I declare it. And so I'll create a new scanner that looks at system.in, the input stream. Perfect. And here, just to keep everything as readable as possible for me, when I get a line of code that's too long, I want to align my comments because that makes them much more readable. So I'll go back and I'll reset my comments from the prior two lines so that they're in line with this comment. So then the next thing I want to do is I want to declare an average. Well, we know we want that to be fractional, and I will call it average. So again, we want to be very articulate with our variable names. And we can actually grab those variable names straight from our pseudocode. Okay. The next thing I want to do here is repeat. So let's throw that off to the side for now. So here, just for the purposes, I can use a for loop, because normally we'd say for counter-controlled loops, we use for loops. But for the purposes of this application, just to keep everything as clean as possible with the way that the logic is drawn out, I'm going to use a while, which is completely fine. So here, while my count, which starts at 0, is less than 10, right? That's, I think, satisfies this line here. And then everything in between is in this block. So actually, I have these indentations here, but actually let me indent these so it looks more like that. So let me open up a block of let me open up my implementation and then close it now. So now the block of code contains the comments that represents my repetition statement. And then here, this is going to be a output system.out.print. I always like print F. Enter a grade. Or I'm going to do enter grade, and actually let me do %D, and it'll actually give me the number of grade that it's asking me for right now. And then here, I'm going to actually pass it the variable. So I'm actually going to create a prompt that allows me to see what grade number I'm on. And actually, I'm going to add 1 to it because my grade count starts at 0. So this way, it'll say grade 1, grade 2, grade 3, grade 4, grade 5. And what I'll do here is I will now bring everything else into alignment in terms of my comments. Bring it. Perfect. So now these are all lined up so I can easily read them. So the next thing I'm going to do is I'm going to get that grade. So it's going to be a double. Nope. Let's push that off to the side right now. So double grade is equal to, and then from my keyboard, I'm going to grab the next double. Then here, we're going to then take, and to our sum, we will add to it the grade. And then finally, for our count, we'll increment our count by 1. Perfect. So that represents that block. Then finally, I'm going to set my average. So now average is going to be set to what my sum is divided by my count. And then finally, I will do a system.out.print F. I'll put that average is %D, %F, and a new line character. And then here, let me also go ahead and put average. Perfect. And I think those are the Java statements that line up in parity with the pseudocode. Would you not agree? So you want to see if this works. You want to see if we appropriately defined our algorithm. Let's check it out. Let's test it. The next thing we always do. So in the process, so in this design pattern, what we're doing is we plan, and we planned on paper, then we implement it in Java. And the third and final step you should always do is then test to make sure that everything works the way you expect it to. First of all, let's see if it compiles. It compiles. And then finally, let's go ahead and run that. Okay, so enter one grade. Let's say that you have a 58, and then enter a grade 2. Let's say you have a 90, and an 88, and a 67, and 99, and 86, and 95, 77, 66, and finally a 34. And then we'll get an average of 76. Is that the correct average? Did this work well? We don't know, right? Illustrates that might not be a great test if we put in data and we can't validate that it's right or not. So why don't we do something easier? Because that's one of the important things about testing. You want to actually make sure that it's working. So we definitely get a result though, probably correct. Let's test it one more time, but now use numbers that we know are going to be correct. So what's a way that I can definitely get an average that's been computed, but that we can compute in our heads? What if we did, say, for instance, what's that? We could do the same number. I'm going to do two different numbers and just see if it takes the halfway point. So I'm going to do 0, 0, 0, 0, 0, then 100, 100, 100, 100, 100. And the average is 50, which is exactly what I expect. Excellent. Does anyone have any questions about this? Does everyone see how we evolved from the top statement all the way to having a complete application? And this process is scalable. It's scalable to being able to develop software that is hundreds of thousands of lines of code. Using this same approach, if you're starting in an abstract space and you keep iterating, adding just a little bit of detail, adding just a little bit of complexity, a little piece at a time, and doing that again and again and again until you've matured your thought process, your step-by-step instructions until it's complete and ready to be implemented. Okay, let's do the second thing. Let's go back to, so we've done the counter averager. Let's look at what we have to do for a sentinel averager. So we're going to create a top statement, and notice the slight difference in this top statement. Determine a student's average for any number of quizzes. So now that represents a sentinel value, any. We don't know when to stop with any. We know to stop with 10. This adds an additional complexity to us. But the first refinement, notice I'm going to effectively think of doing this piece of software the same way. I'm going to say, okay, the first thing I need to do to be able to determine a student's average for any number of quizzes is I need to initialize the data, right? That's our data model. Again, mapping this back to the concept that if I were authoring a recipe, the first thing I need to do is figure out what is the set of ingredients that I'm going to use to build out my recipe, right? Before I give the step-by-steps, you have to have the checklist. So I'm going to create my data that I need, my initial state of data that I need. Then the second thing is I'm going to get all the grades from the user and sum them. That's slightly different, not 10 grades, but all the grades. And then finally, I'm going to calculate the average and print it. So notice at this level, steps 1 and 3, they're still abstract, but they're pretty similar to the last application we built. But step 2, already at this stage, is slightly different. So now I look at refinement 1 and I ask myself, is there enough data here for me to be able to go ahead and map this directly into a set of Java statements? And my answer is no, which means I have to go through another iteration of this refinement process. So again, mapping a statement from refinement 1 and expanding it to the left-hand side on this slide, I'm going to say, well, when I say I'm going to initialize data, now I have to think hard and deep. What are the ingredients that have to be used for this application? What are the data? What is the data that I start with? And what do I know ahead of time? And what am I looking for while I'm processing the result? So it's going to be very similar, actually. I'm going to initialize a sum to 0. I'm going to initialize a count to 0. I'm going to initialize a scanner object for input. I'm going to declare an average. So everything's the same in terms of that part of my refinement process. And actually, let's look at part 3. Let's skip out that part 2 right now, go to part 3 and say, well, let's see how similar part 3 is. Same. Once I'm done getting all of the grades from the user, I just go ahead and set the average to be equal to whatever the sum is and the count, and then print that out. So the only distinction here is going to be in the second part of refinement 1, where I get all the grades from the user and sum them. And so here, I'm going to use a sentinel value. So the sentinel value here, so let's do an observation. The user has to alert our application on when it's done processing values. And our application at the moment is always looking for numerical data, right? So every time we try to pull a grade, we're using next double. But what we can do, what the word sentinel value implies is that I can create a special value that doesn't represent a real grade, but it represents a value to the while loop that it should stop. So let me ask you, what is a good example of a sentinel value that can be represented as a numerical data, as a double value, but doesn't represent what you could really get as a grade in a class? A negative number. You should never be allowed to get a negative grade, because think about that. You would have a higher score by not taking it than if you took it. Like, that's absurd. The lowest grade you should ever be allowed to have is a 0, because that's the same as not taking that test to begin with. It'd be a ridiculous class that allowed you to get less points by taking a test than by just avoiding it. So, with the understanding that the lowest valid grade is 0, then we can map a special value to a grade that is less than 0. And let's say for all intents and purposes, we use the value -1, but it could be any negative grade. So that will apply to our loop. When you see a negative value, something less than 0, that's when we're going to stop. That's the sentinel value that says, stop processing grades, we've hit the endpoint. Now, if it's a positive value or it's 0, then we'll add that into our average. So the first thing we're going to do then is then prompt the user for a grade, with the understanding that that grade could potentially be -1 to begin with. Perhaps they launched the application by mistake. So we need to give the option to the user to kick out and do a -1 to begin with. That's why this prompt is before the loop. We need to get a definition of grade before we decide whether we're going to execute our block of code or not. So we're going to prompt the user for input. So enter a grade or -1 to quit. Then we're going to get and store that grade from the user, and we're going to repeat this process until the value they supply to us is less than 0. And this process is going to essentially be prompt the user for another input, which would actually be the first grade, then get and store that grade from the user, add the grade to the sum, and add 1 to the count. So that's almost fundamentally the exact same. Now, in order to preserve time, instead of stepping through this entire process all over again, would it be okay if I just update the part of my algorithm that we've changed? Okay, So I'm going to copy and paste. So let me go here. I'm going to take counter averager. I'm going to duplicate it. And I'm going to rename it to Sentinel. And I'm going to pull that in here. And I'm going to change the name here. Nope. There we go. Okay, so now that we have our name changed, so the part I'm going to, really the part that I care about is this. That's what after, and also the top statement. So the first thing I'm going to do is let's take our top statement and update our top statement so it's consistent with what this particular application does. So this, the earlier one said to 10 grades. This is going to say we want to determine the student's average for any number of quizzes. And then here, let me go to this refinement step. I'm going to grab this part here, and I'm going to delete this. I'm going to paste in this new pseudocode. Let's go ahead and toggle this to be line comments. And here, perfect. And I want the indents to see where my while loop in my pseudocode begins and ends. Okay, so let me update here. So just using, again, my pseudocode, I'm going to say system.out.printf. Let's tab that out. Enter a grade or -1 to quit. Okay, so I have a prompt. So now that I have a prompt, I'm going to then get a value for grade. So grade will be equal to whatever the keyboard.next double is. Then I'm going to create my while grade is greater than or equal to 0. And now, whenever I have any control structure, I have to give it a block of code, a block of statements. So I'm going to open and close my block now, and I'm going to indent in here to represent the code that's affected by this while construct. Okay, so now what I'm going to do is I'm going to cheat. I'm going to copy this line here, and I'm going to paste. So we're going to have the same prompt. Then I'm going to cheat. I'm going to copy this line here, but I don't need to declare it. It's already been declared. And I'm going to do that. So here inside of my while loop, I'm going to do the same thing. The only time I enter my while loop is that they gave me a grade. And in fact, what I want to do is if I did this, I want to do this last actually. Right? Because that's the update to my loop control variable. If they gave me a non-negative number, then I've entered the while loop and already have a valid value of grade, right? So I should just save that grade, and I should add it to my sum, and I should add it to my count. So notice I've already identified while coding this a flaw in the logic. The order of operations was wrong. Does everyone see that? Did you see why I had to maneuver the order of operations? If we're going to get a grade here, and if it's a non-negative grade, then they gave us the first grade from that needs to be added in. So I'll grab it and I'm going to add it to sum. So here my sum is going to be whatever that initial grade is. And then I'm going to have my count and increment my count. So notice I'm doing those steps first in this time around. And then after I take the grade that I grabbed outside of my while loop, after I take it and add it to my sum and add to my count, then remember, one of the things we have to always do whenever we define a loop is we have to define the loop control variable. We have to define the terminating condition for the loop, and then we have to update the loop control variable. So what's happening here is by getting a new value from the user, we're updating grade, which is our loop control variable. We're evaluating the value of grade, and we only stop when grade is -1 or any negative number, right? So does everyone see why I had to change the order of those statements for this to work? Excellent. Well, let's test this out. Let's clear this. Let's do Java C, Sentinel, Averager. And now let's run Sentinel, Averager. So enter a grade or -1 to quit. So let's start by giving it a -1. So what's going to happen if I give it a -1 right now? Yeah, it's going to stop. Oh, it even tries to do an average. Average is NaN. Okay. So we don't process anything there. So let's run it again. And let's try to do, actually, I'm going to make one more revision. I'm going to remove this other prompt. Number 19. So I'm just going to, inside my while loop, I'm just going to take whatever the grade is. I'm going to add it to the sum. I'm going to increment the count, and then I'm going to grab the next value from the input stream, and I'm going to repeat that until I have a negative grade. I'm only going to use the original prompt. So let me kill that. Let's clear that. Let's recompile, and let's see how that works like that. So here, then I should be able to do like 100, 90, 90, 80, 100, 80. What should be the average in this particular sequence? Well, I have two values that are hundreds, two values that are 80, and two values that are 90, right? So likely I should have an average of 90, right? And let's see, and I did get an average of 90. And notice what's nice about this application is now I can just average 2 grades if I wanted to, right? Or I can average any arbitrary number of grades. Okay, excellent. Is there any questions about this? So after doing this a second time, are you feeling a little bit more comfortable with this concept of this top-down stepwise refinement process? Where again, we start with the top statement and we keep evolving refinement after refinement after refinement until we get something we're satisfied with. And then we make use of that. That's not just wasted time. We get to use all of that work we put in as our comments, our line by line comments, and our initial summary comments at the top of our code base. No, with this, I can do any, until I hit -1, it can be an indefinite number. So, and I can do it on different lines too. So let's say I could do 100, I could 90, I could do 80, I could do 45, 65, 77, 23, 45, 35, 78, 98, 100, 88, 99, 27, 65, 82, 0. And it'll give me an average. And again, that's supposed to be the powerful component of this version as opposed to the last one. The last one, you could not have fewer than 10 grades and you couldn't have more than 10 grades. you only ever got an average for 10 grades. So that wasn't a very flexible averaging application, right? It's tailor fit for a class that explicitly only has 10 grades that has to get averaged. Whereas this is much more flexible. This is a much better application. I can still average 10 grades with this, or I could just do 2, or I could do 20, or I can do 10,000. Excellent. Okay, so finally, I want to use this process one more time. I probably don't have enough time to actually walk through it in our lecture today because I have 4 minutes, but I want to motivate it. I want you to think about it and see if you can't build up your own refinement before next lecture. So we're going to meet on Tuesday. So one thing I'd like you to do, and this is see if you can't create pseudocode for this particular application. So I'll give you the top statement. What direction am I going in? This one? I don't remember where okay. So I'll give you the top statement for the last thing we're going to want to do. It's going to be a calculator. And so the top statement is we want to solve a mathematical expression, an arithmetic expression from text. So it'll be one piece of text. And so what I mean by that, let me give you an example. Example, 2 plus 2 will be, so there will be a space. So it'll be the same way you would normally define a mathematical arithmetic expression. It will use binary operators. It will have a left-hand operand. It will have an operator, and then it will have a right-hand operand. So the text will always be formatted where it has some piece of numerical data followed by a symbol that represents a mathematical operation followed by another numerical value. Now, the symbol could vary. The symbol, for instance, let me do the following. Let me show you different possible symbols with the same set of mathematical values. And I know for the most part, okay, let's walk through some of these now. On here, what should be the result of this first example? Okay, what should be the result of this second example? What should be the result of this third example? What should be the result of this fourth example? What about this fifth example? What about this example? And finally, this. That's a modulus operator, right? So we'll build a modulus. So let's constrain ourselves to an integer calculator, in which case this will produce a 0 and this will produce a 2. So notice when we start talking about mathematical expressions, it's possible that we can have more than one symbol that represents the same mathematical operation. We might want to take that into account when we build out our application. So what I want you to do after seeing these examples of mathematical expressions that are represented in the form of text, and by text, I mean, these are in a string format. So you can think of these as string literals, right? Where you have double quotations encapsulating these. These are what's being provided as the initial sets of input into your application. What would be the process to actually convert this into the result that you just did mentally for me? And so I'd love everyone to go ahead and practice what we just did today. See if you can't develop your own set of pseudocode, even convert that pseudocode into an application. And then next class, we'll actually walk through it and see if your refinements are similar to mine, or if your end result is similar to mine, or how similar they are, or how different they are. So this is a great way to challenge yourself and then compare and contrast. Does that sound good to everybody? Yes. make your own pseudocode. And if you feel so apt, try to even test it out in Java. See if you can even just convert it the same way that we spent today doing that. I'd love for you to try that. And then what we'll do is we'll actually look at my solution next lecture. And so I think this will be a great way just to make sure everyone's on the same pace before we start adding more complexity in how we design our software. Excellent. So is there any questions that we have before I dismiss class for the week? No, I did not do attendance today because, yeah, so I will randomly do attendance. I do stochastic attendance. No, I'm going to push that back. So I just need to log into Moodle. Unfortunately, my time schedule has been so insane this semester that I'm trying to juggle too many things. And I gotta send me a reminder if it doesn't get pushed back, just so I know. Because when I leave this class, I instantly jump into the mode of the next thing that I have to get done. So, but keep in mind, though, when I tell you these things, like I'm usually really flexible with homework turn-ins. Though, let me be frank with everyone here now. I much rather you turn something in late, but something in that's good, as opposed to turning in something that's poor, but on time. I will not give you a late penalty if I can see that you invested time in getting the work done. Where it becomes problematic is if you're both late and you have poor work, because it means you're not learning anything and you're not putting any effort into anything. So don't be super stressed about the due dates. I have the due dates because you want to hit those due dates if you don't want to get so far behind in the semester that you get lost, right? Like the due dates are milestone points on where I think you should be, but I'm not going to penalize you if you miss that, especially if you're super into the assignment, since I give you options for creative expression. Because remember, you don't get a grade on your assignments until you coordinate to do an audit with me. We didn't do that for the first assignment. Oh, I didn't apply it for the in people. I think all the online people have grades. Yeah, I'll also update your grades for the first homework. For all the future homeworks, for homework 2 and moving forward, though, you have to set up an audit with me where you show off what you've done. And that's when you're going to get a grade for those assignments. Excellent. Okay, any other questions?
Where are we at on tutoring?
We have a set of tutors who have been selected. We're finalizing the paperwork so that they can start working, because the tutors don't want to start working until they get paid for working. Now, I will say that we have some really exceptional tutors that I'm excited about this semester. 2 of them are master's students, so they've completed their bachelor's degree in computer science. And we will have tutors available 6 days out of the week, Monday through Saturday. So we got great coverage this semester. And the hours, because I put together the schedule, will be approximately between 11 to about 5 each day. So you'll have good coverage over the course of the semester. We're just waiting to get all the work processed by the university so that we can put them into the, and they'll be working both in person upstairs on the 3rd floor, as well as having a Zoom link. But again, there's usually one person on duty, so there could be a queue at any one time. So do keep that in mind. Any other questions? And of course, also use Discord. Ask questions in Discord, and we can crowdsource problems that you might be having, so you're not reliant on the tutors 100%. I would prefer that. I would prefer. So one of the reasons why I do the audit is, again, one of my primary roles is as the industry liaison. I communicate with our industry partners to find out what skill sets they want you to have to be as marketable as possible. And so the feedback I routinely got was that the technical skills of all of the students coming out of this, all of our alumni coming out of this program was very strong, but they wanted me to find ways to increase what are called soft skills. Soft skills are your ability to communicate with a variety of stakeholders, whether it's non-technical people, whether it's technical people, or whether it's managers who are non-technical, but their stakes are different than a client, right? Clients care about features, managers care about where the money is going and why it's worth investing in the 3 weeks to get this feature made. So it's important for you to be able to communicate verbally what you're doing. And that's what these audits allow you to start practicing. I get to pretend to be your lead developer, and you're doing check-ins, you're doing stand-ups with me, where you were assigned a task and then you get to show off what you've done. Does that help answer your question as in line? And so for that reason, I prefer for you to be complete before we do the audit. Now, I will do audits for incomplete work if you need a debug session. Don't feel like you're isolated by yourself. If you're stuck and need help, and I've already done this with students in this class, you can show me your code. I prefer to look at code on Discord as opposed to doing a video session, but you can share your code with me in a direct message and I will help you debug it. I've already done that with students in this class. You just send me a direct message in Discord. And as I get busier, I'll actually start posting when I have audit schedules. But right now, my schedule is effectively blank. Any other questions? Excellent. Okay, everyone have a great weekend. I will see you on Tuesday. Yes.